Hello everyone. In my last video, I talked about how we can take a derivative of a function using the very first principle of calculus, which is differentiation from first principle. The formula is written above, and we will try to understand how we get to the power rule. Power rule is if f of x is equal to x squared, the derivative of f of x would be 2x. But why is that? And I have written a problem here which says if f of x is x power n, prove that f differential of f of x would be n into x power n minus 1. So we will prove that by using the first principle of calculus, differentiation from first principle. And to get to here, we know this, but we don't know this. We have to find the f of x plus delta x, and it is x plus delta x the whole power n, and in this step we have to use binomial expansion. It is pretty easy, which is going to be x power n plus n x power n minus 1 delta x power 1 plus n minus 1 by 2 x power n minus 2 x delta x power square delta x square plus, and in the last term we will have delta x power n. This is the basic concept of binomial expansion, and we know that. So in this step I will try to factor out all the delta x terms from the second term, starting from the second term, because we don't have delta x in the first term. So if I factor out this, there isn't going to be any delta x in the second term, so plus n minus 1 by 2 x power n minus 2, this is going to be delta x power 1. And in the last term we will only have delta x n minus 1, because one of the delta x is factored out, so we will have one less than the original value. So let's just leave this to that, and we will substitute the equations in our formula, which is going to be f of differential of f of x equals limit of delta x approaches 0 and f of x plus delta x minus f of x by delta x. We know f of x plus delta x, and delta x is delta x. Yeah. So we will just rewrite this. This is going to be this value. We will substitute this in this formula: x plus n delta x n x power n minus 1 plus n minus 1 by 2 x power n minus 2 delta x all the way up to delta x power n minus 1. And this is for f of x plus delta x, and we know f of x is just x squared, and the whole divided by delta x. So in this term, x power n and x power n's cancels out, and we have delta x and delta x from above and in the numerator and denominator, so we can cancel those out. So what we are left with is delta x approaches 0. We will have this term left out. We will just rewrite this, and x power n minus 1. From this step we can now see where this is going. So x power n minus 1 minus 2 delta x minus 2 for x plus x minus 1. So limit of delta x approaches 0 is a mathematical operator. This says that delta x would approach to 0. When delta x approaches to 0, what changes would be in a function. So if delta x equals 0, all of this would be equal to 0. And the one I boxed out would all be equal to 0. So what is left is n equals we have used this operator, so no use of writing it. So only this one is left, because delta x approaches 0 and all the other terms in the expansion are equal to 0, so we don't have to write that. So our differentiated value would be f prime of x equals n into x power n minus 1. So we have proved that if f of x equal to x power n, f prime of x equals n into x power n minus 1. So yeah, this is the proof we have done by using the first principle, differentiation from first principle, and all the other rule like quotient rule and product rule can be done like this, but it is a bit complex than this proof. So yeah, I will just leave it to this, and I hope you get it. Thank you very much.